Hi there, I'm John McArthur, I'm the Managing Director at McArthur Agriculture, and we're one of the partners on the NCS project, and we are working on the processing of beans, looking to add value to homegrown, British-grown beans for end users in livestock feed. So what we're doing is we're taking a feed bean, which has been grown very close to here, about 30 was Lynx. It was a spring bean harvested mid-September, a little bit late. They came in actually reasonably dry, which was nice for this harvest. What we've done with this sample here, we've cleaned that with the JK Machinery Vibro Compact Cleaner here, just to take out the pods and to take out the fines and the weed seed that are in there. So what we've got is we've got a reasonably clean sample there of faba beans. Now, we're really looking at testing two processes. The first process is the dehulling process, which is taking the outside of the bean away from the kernel. And then the second process is the roasting process, which uses these machines, which then exposes the bean to a very high temperature air for a short duration of time. And what we're looking at is we're looking at how this can be used to add to the nutritive value of beans and look to replace soybean meal in various livestock sector rations. What you have on this machine, you have two vibrating motors at the rear of the machine here with offset weights which shake the machine, which provides the shaking action for sieving the beans. The top screen here and the lower screen here enables you to split the beans physically by dimension, by size, into three fractions. So you can have an oversized fraction, large fraction, which sits on the top of the cleaner, and that drops through this chute here. You have then the main fraction, which sits on the top of the smaller, finer grading screen, and then the very fine seeds and particles and admixture drop through to the bottom. Now, that kind of central fraction, which is the majority generally of the grain, then passes through what's called an aspirator on the end of the machine here. So those beans, they come through to the end and they drop down, and as they drop down, this fan sucks a lot of air at high speed past the beans, and what that's doing is that's lifting anything that's light away from the beans, and that's just controlled with these simple valves to control the speed of the air which is going past the beans, and that gets carried away to the cyclone at the end there where the dust is settled out. So what we have here is the JK Machinery JHP07, which is a peeler, but it's a dehuller for pulsers. Now what you have here is the beans load here and the inlet at the top of the machine here, and then what you have is a shaft through the middle of the machine with a series of paddles along that shaft, and what that's doing is that's driven by this motor here, and that's spinning and that's pushing the beans into contact with a cylindrical stone face that's up the inside of the machine. And what that's doing is that's basically, through abrasion, that's ripping that hull off the bean and removing the outside of the bean. And so what you end up with, the outlet here, you'll recognise this as another aspirator, same principle as the cleaner, where you have the hulls and the bean kernels falling together, and then this high velocity air is passed through that falling product, and it lifts the hulls and some of the bean flour, the light bean material out, and separates that in the cyclone. So from this machine you end up with two fractions. So you're putting in what was cleaned out of this machine into here, and then what you're doing is you're separating that into the kernels and what is predominantly the hulls. So this machine here is the McArthur T5, which is a roaster. Initially designed about 25 years ago for actually roasting and heat treating soybean, because soybean has a trypsin inhibitor which needs to be exposed to a high temperature for a short period of time. So it can actually be used in livestock nutrition. Without that, it's actually a very little feed value without the heat treatment. You have an oil furnace at the front of the machine here, which houses the oil plume in the furnace here. and then the air is pulled from the front of the machine by this fan. It's pulled from the front of the machine, picking up the heat from the exhaust air from the process, and the air is then put through the furnace and blown up through a perforated floor in the conveyor section of the machine. So that's how the airflow is working. Cool air is coming in, it's getting preheated by the exhaust air, then the fan is putting that air then through the furnace, which is using the oil burner to provide additional heat, raising temperatures anything from 180 up to 240 degrees centigrade. Over there we had the oil fired system, and McArthur, the manufacturer, noticed when using that it's quite an energy inefficient process. There was quite a lot of wasted heat from the process, and that actually led them to design this machine here. Now this is the TX2, and it is a much more energy efficient roaster, but it does also have a slightly different process to the T5. Now this uses electricity. It is as green as the grid and could be run off renewables, needs quite a small supply, and there's no fossil fuels associated with this process. But what we don't have is we don't have as much information about the beneficial and the value added effect that this can have on beans that we do have for the oil-based roaster. So that's one of the big objectives for our part of this project, is to understand what can this machine do in terms of protein protection, in terms of reduction and impact on anti-nutritional factors, and also palatability. Very simple machine. The beans are entering in the top of the machine here, and they fall through a central column where the roasting air is recirculated within the machine, and then it's dropping out the bottom, controlled by a roller discharge mechanism at the bottom of the roaster here. What this machine does is it not only roasts, but it also then cools the product as well, which with the oil-based system is a separate process that needs to be done. So this really is, all in all, a very energy efficient plant, because it's providing a roasting and a cooling. But what we need to do is we need to understand just exactly what are the optimum parameters and just exactly what can it do, so then nutritionists can see how can we reformulate livestock rations without the use of soybean meal and instead using heat-treated pulses. So we've had a look at the two pieces of roasting equipment up there, and what we're going to be doing on this experiment over the next couple of days is not only are we taking a clean bean and dehulling it, we'll be also roasting this dehulled product through both the oil machine and the electric machine. Okay, and what that will do is that will give us a product something along these kind of lines. So this is a little bit of trial work we were doing. This is a little bit of a blend of all sorts. But two things you'll notice when we're roasting the beans is that one, the smell is really nice. And so what you're doing is you're exposing the beans to that high temperature for a short period of time. It starts that Maillard reaction, and so you get a sweetness. And so what you find, beans when you're feeding them, typically very bitter and not always that palatable. If they're not palatable to you, they're not palatable to your cattle either. So over the next couple of days, what we're aiming to do is we're wanting to get to understand these machines, the dehulling and the roasting machines, and that process a little bit better. And we're going to be working with another one of our partners, Jos Houdijk from SRUC, and also Dave Davis from Silage Solutions. And we're going to be looking at what benefits we can infer with the dehulling and the roasting from both a monogastric and a ruminant perspective. So we're really looking forward to getting some more product through the dehuller, getting some more product through these roasters, and starting to try the different variables and experiment with those. And we're going to start then taking the samples for analysis. And from that analysis, what that will do is that will inform further roasting trials which will be held most likely next autumn, if not maybe a little bit earlier, and also digestibility trials that are going to be completed at SRUC. So what we are doing here and understanding the nutritive value that we can add to beans through these processes, that can ultimately be done on farm, that will allow other work package partners to understand how to formulate rations to be able to feed more British pulses in place of imported soybean meal in British livestock rations. Keep in touch with the project, sign up to PulsePep, and we'll keep you posted.